Hello, thank you very much. I'm actually going to be doing this talk with my friend, Bunny. My daughter asked me to bring Bunny with me, so can everyone just say, hi, Bunny? Hi. Thank you very much. So I'm Sean Metcalf. This is from Workstation to Domain Admin, Why Secure Administration Isn't Secure and How to Fix It. So I'm Sean. I'm the founder of Trimark, a company that helps organizations better secure their Microsoft environment, including the Microsoft Cloud. I'm a Microsoft Certified Master in Active Directory. There's about 100 in the world, most of whom work for Microsoft. I do not. I've spoken before at Black Hat. I'm very excited to be here, so thank you very much for being here with me. I'm a security consultant and researcher, and I own and operate 80security.org, which hopefully many people have heard of or used to help secure your environment. So there's a number of things I'm going to talk about during this presentation. I'm going to talk about where we've come from as far as administration, what it looked like, as we've advanced, what we've done over the years, and the weaknesses that are still inherent in those processes, as well as the things that are currently considered secure administration and why they aren't. And then I'm going to close up with how to better secure your environment and how to better perform secure administration. So many organizations have upgraded their security. We've added better visibility through security tooling, event logging, auditing, EDR tools. We have blinky boxes. We've flowed all these security events, hopefully, many of them, into our SIM tool. We're watching those. We're getting alerts. We've done all of these other things to lock down secure workstations, to have better control of it, better visibility in our environment, but rarely have we actually done much to secure or improve the way that Active Directory is administered. We need to do better, based on what I've seen. So let's start from the beginning. In the beginning, we had a workstation, and we had a happy user on their workstation. And this user had problems. So we added desktop support. And desktop support meant a bunch of other administrators with remote access or local admin access on that system. And after desktop support, we realized, well, we need to patch these systems. There's vulnerabilities we need to fix. So we added patching and agents associated with patching. And then ultimately, we realized this was too much to handle with all these different systems. We needed to integrate it better. So we set up a mission control types configuration. And with our mission control, we had better central management and control of our environment. But the result of all of this is that we have a workstation that has 30 accounts in the local administrators group, which could be a mix of AD accounts and local accounts. We've got about 50 accounts with local admin rights through this management system. We've got 20 accounts with control of the computer through security agents or tooling. And we end up with about 100 accounts that have admin rights. Now, these numbers might be off for a lot of organizations, but I'm sure there's some people here that are trying to hide their head right now because that's a very similar scenario. Because ultimately it comes down to who has control of the workstation. Who are the administrators? Who can control, manage, modify that system? And what if the administrator of Active Directory actually uses that system? So let's take a step back and go through the evolution of administration. We went from using something like VNC to RDP. We were using run as in order to run our MMC and a lot of other acronyms. But in the beginning, there were admins everywhere. We had administrators, we had domain admins. Oftentimes, user accounts were actually domain admins in some situations. Every local administrator had the same name and password across the organization. And some environments actually had as many domain admins as users, which is the ostriches here. I can't tell if they're users or admins, but there's a lot of them, so that's bad, right? And this resulted in a situation where we have an environment that's target rich. The attacker gets into the environment and they can just kind of pick and choose what they want to use because there's credentials everywhere because of the way we've been managing our systems, the way that we still manage our systems. Most of the time we're using a user workstation, a standard regular user workstation. We log on with a user account and then we perform our administration through RDP or some other method. So when we talk about where we were in the old school admin methods, like I said, logging onto the workstation as an admin, we probably don't do that anymore, hopefully, because credentials were in LSAS for that. We don't really use run as anymore on our workstations because, again, credentials end up in LSAS. But we do often RDP to domain controllers or admin servers. and manage them. But that means the credentials are in LSASS on that system. So if we're connecting to an admin server and that admin server isn't well protected, then an attacker could use something like Mimikatz to extract those credentials and reuse them. Like this. So where we are now, we have newer, better, secure admin methods, right? We said no more to run as. We said no more to local MMC activities and administration. When we use RDP, we are going to use NLA, network level authentication, which prompts us for our credentials before we connect to that system. And sometimes we're going to use MFA. In fact, I've noticed more and more customers and organizations are using MFA, which is great. Others are starting to use password vaults, enterprise password vaults like Dichotic Secret Server or CyberArk. So let's talk about how we could exploit the typical administrator. So here we have a regular workstation, and just a regular user named Sean is logged onto it. So he needs to do some work, so he's going to run msc.tsc. It pops up that RDP window, and he's going to type in his credentials and do what he normally does as an administrator. But behind the scenes, there's a file that just gets dropped into the C drive. This very interesting file, this temp file. Well, what is this temp file? So the attacker, behind the scenes, completely in stealth, has performed a WMI implant method to drop a task, a WMI task on this system, that whenever mstsc.exe is executed, a special PowerShell script is going to be run that I've decided to call SCCM Health Check. Sounds good to me. All right, but what does SCCM Health Check actually do? And did Microsoft write this? So we go forward and look and see, well, that doesn't look like SCCM Health Check. That looks like something very different. So when we are trying to figure out what's going on and we're digging through this, we're going to see that this is the get keystrokes PowerSploit function. And what keystrokes does is a PowerShell script or function is actually going to capture the keystrokes while it's running to a text file. And that happens to be that temp file that dropped to the C drive. Now it could go anywhere on the system it wants, but it's going to capture every single key press that happens on that system. And it can be quite extensive as it captures this information. The WMI task could also have that text file get copied off to another location or uploaded to a website. And using PowerShell, I can go through and quickly extract the information from this text file and pull it together. And when I do this, I can very easily identify, assuming that someone typed it in at this moment, what the server name is, what the username is, the admin, and the actual password. So now I have the credentials. And guess what happens if this is the domain admin account? Yeah, I can use something called DC Sync. So this is very dangerous. And even if I add MFA to the situation, I don't need to use MFA when I'm running DC Sync because it's just an LDAP call to the DC. So let's talk a little bit more about this. What if we add MFA? We can MFA the RDP, so then we RDP, it's MFA'd, and we got everything covered, right? Well, we have our RDP connection. We get our Duo prompt. I'm not picking on Duo, but apparently they were in the news recently, so I figured I'd use them. And so when we click on this push, we get a pop-up on our mobile device. And we have two options. We have approve or deny. And looking at it, we decide, yes, this was me, I'm going to approve that. But what would happen if I got two of these back to back? What if I click approve on the first one, what do I do to the second one? Well, the obvious answer is I deny it, right? But how do I know which one is mine and which one isn't, or is this a hiccup? And the same thing can happen with ADFS or on my mobile device itself. If I just look at the lock screen and it pops up, I'm going to go, yeah, approve, I just did that. But what if another one pops up? Was that me, or did it hiccup, or was there a problem with the operating system on the mobile device or the app? What if there's a third one? Will a user report this? Will a user report something that's odd that's happening with MFA? What if the attacker can initiate or initialize MFA requests at around the same time the admin is using it? Everyone's very busy. When we get prompts like this, our tendency is to click on it. Just tap, tap, tap. Oh, did the second one pop up? I don't really know. That's okay, it'll be fine. So what if there was a way that an attacker could actually subvert the MFA system? So here's a scenario that I'm going to put together. We have this fictional company called Acme. And Acme has a self-service portal where users can go in and manage their own attributes. These are some standard attributes like work phone number, work address, mobile number, et cetera. So pretty standard. A lot of organizations have this configured. Attributes may vary. So let's say that our admin, Luke Skywalker, has a user account and an admin account because he's a smart guy. And so he has his mobile number set up in here on his user account. Well, if the attacker can leverage the self-service portal, they can change it to 867-5309 because that's what any attacker is going to use as a phone number. It's easy to remember. And once he has that, or this attacker has access and the ability to change that mobile number, things get pretty interesting because in Duo, by default, or at least in the configurations I've seen, as well as other MFA configurations, there's a backup to the standard app push, which is, yes, SMS or text. So oftentimes it pulls this information from the Active Directory user account for the phone number it should use for that text message. So if the attacker has the credentials of that admin account and they want to leverage MFA, one thing that they can do as an option is modify that phone number, that mobile phone number, and have a text message sent to their phone. And the actual user who owns that account and it counts doesn't see anything. There's no message that goes to them at all. Now, there's similar situations with other MFA systems. And so just a summary of this, if the attacker can modify that phone number, that mobile number, for that user account, which is used by the MFA, and that backup SMS text messaging system isn't disabled, there's a backdoor away to use that account. And if these are admin credentials, then it could potentially be game over. And it's possible that no one will notice. Now, another interesting thing about Duo, again, I promise you I'm not picking on Duo. They're just very popular. And like I said, there's a lot of activity about Duo recently. But there was an article recently, a blog post about Duo and fail open versus fail closed. So by default, Duo fails open. And Duo uses a request via DNS lookup and then a connection to its API A record under duosecurity.com. So if an attacker is able to actually block that connection, what happens is MFA doesn't work at all. So you can change this setting, obviously. And there's another setting that's interesting here, and that is the ability to remove the MFA requirement for local accounts. And so this way, you can do whatever you want as a local account, but everyone that connects in with an AD account will be required to MFA. So there's some recommendations around MFA. First of all, don't rely on it to protect your admin accounts. Don't let it be the only thing that is protecting your admin accounts. Use hardware tokens or the app, disable SMS if possible. Research fail closed for critical servers. Remember that once an attacker has AD admin credentials, it's game over. They don't necessarily need to go through the MFA system. And definitely walk through the potential bypass methods and implement mitigations and detections. Because it's entirely possible that someone could social engineer their way into switching a phone number, some other method, through the help desk or some other way, or a different MFA app on their device. People lose phones all the time. People have to get a new phone configured. Sometimes they end up changing numbers. So does MFA have value? Absolutely. Please, please MFA all the things. Just understand that it's not a silver bullet and that there are things that can be used to bypass it depending on the specific configuration. Password vaults. So I see password vaults being deployed more and more as enterprise password vaults and as a way to provide more secure administration. Typically, like I said, CyberArk, the Thycotic Secret Server. And they often have what they call a reconciliation account, which is very often a domain admin, that has the ability to bring these accounts back into control. So if you have an account that's stored in that password vault, managed by that password vault, what ends up happening is that reconciliation account will check to see if the password is what it has for that account in its vault, and if it's different, it will reach out and automatically change that account password. This means that very often the password vault itself has a very highly privileged account in Active Directory. And it maintains AD admin accounts in addition to that a lot of the time. And there might also be additional components like a session manager, which I'll talk about in a minute. But here's one of the options for an enterprise password vault that we see pretty commonly. Check out the credentials. So we have our workstation on the left, our password vault in the middle, and our admin server on the right. That's that star. And so what we do is we connect to the password vault, and we, via HTTPS, it's just a website, and then we check out that credential. Copy that password into our clipboard on our local workstation, and then we paste it into our RDP login window and connect to our admin server. It's fairly common, it happens a lot. So what can be done about this? What can I do as an attacker? Again, this is a regular workstation. So one of the things I can do is I can set up my SCCM health check, but this time I'm going to use another function from PowerSploit called getTime screenshot. Or actually, I'm ahead of myself. Get clipboard contents. So I'm going to copy out of the clipboard the contents that are there. And there's going to be another text file that shows up on the computer. And as you can see here, every time I copy something into the clipboard, that PowerShell function is just copying it from the clipboard directly to a text file, constantly and over again. And through this method, the attacker ends up getting that password that's in the password vault. Now, obviously, the password vault's not going to be creating passwords like this, but this is black hat. We're going to be fun. And then I can take that, I can look at it, and I can leverage that account password. But how do I know what the account name is? Well, that's where that getTime screenshot function comes in that I was mentioning a little earlier. Because then what I can do is have screenshots of what shows up and then correlate that with what's in the clipboard. And I can use a WMI implant to this. So there's malware out there right now that is monitoring the web page that people go to via the title. It looks for financial website names. It looks for certain types of title keywords. I can do something very similar. I can look for CyberArk or Thycotic or something like that. And when that happens, through my WMI implant, I can kick off these PowerShell components or something that I custom write within C# to do the same thing and capture this data. So we want to be very careful what systems we're connecting to a password vault from. Okay, well, there's a different way to do this, right? The RDP proxy approach, which is where we have the password vault sitting in the middle. We have our workstation. We're connecting to the password vault via HTTPS. We then connect from the password vault to the admin server via RDP. And the password vault is providing that proxy, that RDP proxy. And the password vault has the credentials. The admin themselves don't have the credentials, don't know what the credentials are. The password vault is doing that entirely. So it's a complete pass-through. And a lot of the password vaults now have the ability to do session recording as well. Although I've never actually heard of someone having a good plan for like going back and watching sessions or randomly looking at them, but it's there. But a couple questions with this approach. First of all, what account is used to log onto that workstation? It's very often a user. And then what account is used to log onto this password vault that then has access to this highly privileged admin account? It's often also a user. And is MFA used to protect that authentication? And what about the administration? Who's administering this server, this password vault server that contains all of these very critical credentials? And what about the network communications? Are we limiting access to this password vault? Most of the time, there's no limitations on the network to connect to the password vault. And a lot of the times, people are just accessing the password vault using their standard web browser, which has all of the other things that are usually in a web browser. So what are the extensions? What are the settings? How is that web browser configured? What if I compromise the web browser? Might be an interesting way that I could compromise the password vault connection from that, because it's all web at that point. So one thing to think about is, should we be using a separate browser when we're connecting to the password vault? Well, maybe. But the other thing I see too often is a situation where there's a password vault admins group in Active Directory, and when I enumerate the membership of that, every member, or most members, are regular users. Anyone see a problem with this? I certainly do. These are the admins for the vault. The other problem I've discovered is, thanks to my friend Shodan, they were able to tell me that there's CyberArk password vaults on the internet, which could be okay, probably not. It all depends on what sort of data and credentials that are being stored in them. And I happen to find one that's a little bit older, which is very concerning, which we'll talk about in a bit. So when we talk about the password vault, we need to look at the potential weaknesses in the way that it's configured. So authentication to the web server is typically a user account, MFA or not, maybe. These are often administered like any other server, so server admins has full admin rights on them. And the sessions that are created by the admins to connect to the password vault are not always limited to one. They should be limited. And a vulnerability in the password vault can compromise Active Directory entirely. So just a few months ago, in April, with the CV at the top, 2018-9843, there was a serialized .NET object vulnerability in the way that CyberArk was handling the API on the password web server. So just for those who have CyberArk, if you haven't patched it since April, I highly recommend you message someone and do that today. Because what this did was it enabled the ability to run arbitrary code on that vault. And the proof of concept is simply just running ping. But you can see that there's a very interesting escalation process that could be done here, because the password vault web server is the one that proxies or brokers that request from the user and identifies which password vaults they have access to, or which credentials that user has access to. We can modify that. If we can change that, we can do a lot of really interesting things. What about the admin forest? So there's been a lot of talk in recent years about the red forest or the admin forest or the ESAE, et cetera, et cetera, et cetera. So the whole concept is that we're going to take our production AD forest, we're going to take all of our AD admins, and we're going to move them into this other AD forest. We're going to completely lock down this other AD forest. We're going to make sure that only our AD admins are over in this forest and they're well protected. We're going to have network configuration where nothing else can connect to it except the authorized systems. We're going to ensure that it's encrypted. The network communication is encrypted. We're going to have a one-way trust. So that way, the production AD environment trusts this admin forest. We're going to have a group in this admin forest that is a member of the administrators group in Active Directory and the production AD, and only these admin forest accounts are members of that group. And we're going to make sure that those accounts in that group that are in this admin forest don't have any admin rights to the admin forest and aren't even in that group all the time. So the only way to administer this AD environment, according to this, is through this admin forest account, which oftentimes is using PKI and separate management, completely separated. So I have a slide here which talks about what I just said. You can look at the slides later. They'll be on adsecurity.org after the talk. But there's some pros and cons with admin forest. The pros are that we are effectively isolating our AD admin credentials into a separate forest where they're very difficult to get to. And when deployed properly, it can be effective in limiting access to these AD privileged accounts. Sounds really good. Where do I sign up? Well, there's some challenges with this. The first one is it's expensive to deploy. An admin forest is effectively increasing your management overhead and costs because you are duplicating your infrastructure. You're setting up new DCs. Technically, they're all supposed to be physical, by the way. They're supposed to be managed by a separate system. Any security tooling and management systems are supposed to be duplicated in that environment. And anyone that logs into that admin forest environment is supposed to use a PKI card, which has a separate PKI from your standard PKI configuration. But ultimately, it doesn't fix your production AD issues. If you have security issues, misconfigurations, if you have delegation that you set 10 years ago and everyone's forgotten about it, and so there's like 4 accounts in your environment that have like 2 steps from DA, but no one knows about it, this isn't going to solve that. In most organizations, we also have workstation admins and server admins. Guess what? Attackers don't need domain admin rights. They don't need Active Directory admin rights. All they want is access to data, access to systems. So if they can compromise a workstation admin or a server admin, or both, they can get that. The other thing is, what about your production AD privileged service accounts? So technically, as part of this whole admin forest, we're supposed to take those privileged service accounts and remove them. Just take them out of domain admins, take them out of administrators, just make them regular users, delegate the rights out. Most of the customers I talk to can't just do that, and so these service accounts that are highly privileged end up sticking around. And so as part of the admin forest implementation, you're supposed to assume breach. That's our mantra, assume breach, right? We need to check the environment to ensure it's configured correctly, that there aren't any of these obvious misconfigurations. But what if it's compromised? What is this admin forest actually going to buy us? Especially when we have to assume that there's an active attacker on the network. Well, not much, because all we're doing is shifting the admin accounts that are known into our admin forest. And any of the sneaky persistent methods that happen to be in the environment, maybe someone is pretending to be a domain controller in the environment that Vincent and Benjamin are going to talk about tomorrow in the DC Shadow Talk. That's not, admin forest isn't going to help us from that. So what should be done first? These are questions and concerns when you're going to spend a lot of money on an admin forest, because ultimately it's been billed a lot of the times as the solution to your Active Directory security problems. And attackers can figure out if you have an admin forest. It's pretty easy. We just look at the trust membership and we might see something that looks like this. And we're definitely going to see another forest group that's in our admins group for our Active Directory forest. So it's going to be pretty obvious when we have that. How effective is the admin forest? Well, the deployment often ignores the production AD environment issues. Organizations are usually very quick to deploy an admin forest and get it stood up and get these AD admins moved over, and these other things don't get fixed. They stick around. And of course, there's service accounts that are still there. There's agents on our domain controllers that still have privileged access, and who has administrative rights to those? Who has control of those agents? They're not in the admin forest. And backup is still a big issue. So I worked with a red team to help them compromise an environment, an AD forest that had an admin forest. We didn't touch any of the AD admin accounts. We didn't have to. So there's definitely some benefits for the larger organizations that have multiple Active Directory forests, because if you have several AD forests, you've got to have a way to configure and manage all of them. So an admin forest might make sense in that scenario. But there's another issue that I've seen in a lot of organizations, and that is the whole concept of cross-forest administration. We have our forest A because I'm very creative at naming things. We have our forest B because I'm incredibly creative at naming things. So forest A is our production. Forest B is our DMZ environment, our dev test, our external. Doesn't really matter. It's another forest that's not as highly trusted as our production, our forest A environment. We're going to have a one-way trust. So in Microsoft parlance, an arrow pointing from B to A means that A is going to, A resource or A accounts, see, I got confused. A accounts can access B resources. So that means our happy domain admin in forest A can also be an admin in forest B. And so this happens a lot, where we have a domain admin in forest A that manages and administers forest B. And so they connect into RDP and go ahead and do what they need to do. Here's the problem. Forest B is not as trusted as forest A. It's in the DMZ, it's dev test. It might have 100 domain admins that are all the developers. It could be an application forest that has some internet connectivity that's not in the DMZ. So what do you think happens when that forest gets compromised? Well, then our happy admin gets compromised, and ultimately, ta-da! Forest A gets compromised, right? A little bit of cliffhanger there. So simply from this trust and the fact that we're using a forest A or production domain admin to administer this other forest, which makes sense logically, and a lot of Microsoft documentation points to this as the way to do it, is problematic. Because when we connect using RDP from forest A to forest B, we often are leaving credentials behind. In fact, by default, we are. So I have a slide here that has kind of a summary of what I talked about, but at the bottom is a mitigation. So we want to make sure that we manage this other forest, this forest B, with a forest B admin account, not a forest A account. Or if you really are set on using a forced A account or a production account, make sure you just create a user account or user accounts that have no privileges in forced A that then are the admins for this other forced, and then protect them at a good level. All right, so I've talked a lot about the problems and the issues. Let's talk about building the best defenses. By the way, this is one of my favorite castles in the world. This is Mount Saint-Michel, which I'm pronouncing horribly wrong, I'm sure, in France. And so for Lord of the Rings fans, this is actually, the castle that was the inspiration of the castle in Lord of the Rings. 80 defensive pillars. We're going to talk about what we need to do in order to secure Active Directory. So we need to protect our credentials, our AD admin credentials. We need to isolate them and protect them at the highest level. We need to harden our admin methods. We want to make sure that we're not using administrative methods that could be compromised. We need to reduce and limit our service account rights. And as part of this, pull out any accounts that don't need to be in domain admins or administrators. And then there's also effective monitoring. We need to make sure that our domain controllers are properly monitoring the correct events, so that way when something does happen, we can see those. Unfortunately, that's out of scope for this talk. I don't have enough time, but I have bonus content at the end of the slides you can look at later. So the key to this is focusing on protecting these admin credentials, especially our AD admin credentials. We need to have a separate AD admin account from our user accounts. Most organizations are doing this now, although the ones that have transitioned recently often forget about some of those user accounts and leave them in AD admin groups. Making sure that these AD admin accounts are different from other admin accounts. They're not administering Exchange or SharePoint or SQL. And use distinct naming. I like ADA for AD admins, SA for server admins, WA for workstation admins, but use whatever works for you. I went into a customer site and they had all these different accounts. Actually, there's been a few customers like this. All these different accounts, different names, different setups, had no idea what kind of naming standard there was. And so I went in and talked to them about this after I'd gone through and done some assessing of their environment. I said, what's the deal with all these accounts? I can't tell. Like there's first initial, middle initial, last name, first initial, middle initial, last initial, and then like Superman, a couple other things. I don't know what this is. Like I don't, like who's supposed to be your AD admins? And they go, aha, you don't know. Yeah, you don't know either. And they said, yes, but the attacker won't know which of these is the admin account. I said, yeah, that's great, but I have this report here that has a list of all of the admins that I've enumerated in your environment from all of the standard groups and the permissions in your environment. So I know who the admins are. The attackers know who the admins are. The problem is that we cannot programmatically identify, monitor, and maintain a configuration without a standard naming convention for administration. If I see that there's 5 accounts in domain admins, how do I know that all of those belong? Who do I have to talk to? I've got to talk to like 6 other people to figure out which of these 5 accounts should be there, right? But if I can programmatically configure the environment to monitor and alert on changes when it doesn't see an ADA in domain admins or something like that, I've elevated my environment to the next level. I can proactively manage and maintain this. And of course, we need to make sure that our AD admin accounts are only logging into AD admin workstations and AD admin servers and domain controllers. But the biggest question is why admin workstations? Hopefully, some of these slides have helped you and will give you some evidence and some ammunition you need to influence others to get admin workstations deployed. Because the issue is the battle is shifted from the perimeter onto these workstations, which we know, but we're still running administration from them. And the management of these regular workstations is an escalation path. There's lots of talks about exploiting SCCM to then own the environment or deploy malware, right? Altiris, SCCM, there's a bunch of different systems that are used to do this. And then the credentials that are found on these systems are used to escalate and move around the environment. And they can be in LSASS, they can be typed into a RDP window or into a web form. But this builds on the whole concept of having a separate account, separate admin account from a user account, which we've been talking about for years, right? Everyone knows since the beginning we've been hearing this. We also have to remember that any agent that can install or run code is a potential compromise method of that system. So we need to expand out our vision from just who has local admin rights to what are the agents that are running on these systems and who has the ability to influence them. So when we're talking about our AD administration systems, we need to isolate and protect these privileged credentials. We need to provide secure environment for the admins to do what they need to do. Ultimately, we need to disrupt the common attack playbook. This means that we want the attacker to have to go from chapter 1, page 1 to chapter 10, chapter 20. And by making it more difficult for the attackers, we have better insight and visibility because we want them to hit those tripwires. We absolutely want the attackers to hit something. We want to set up a pathway that they go down. Jessica Payne calls this building the attacker's playground. As a defender, we have the ability to configure the environment to be our home court advantage. We set up the tripwires. We form and identify which way we want them to go. And we look at that and we go, all right, here's how we do administration. So what are the tripwires we need to implement? What are the events we need to be looking at in this pathway? How do we ensure and know that only valid and authorized people and personnel are using those pathways? So we need to ensure the system is configured correctly. We need to make sure only these specific admins can log on, separate administration of this system, of this admin system, separate management, patching, auto patching in many situations. Make sure it's firewalled off the standard network. We want to restrict access to the management protocols like RDP, WMI, et cetera, and enforce NLA so that way someone has to auth before they connect to that RDP server. There's a great hack or modification that I call movie hacking on Windows. It's just simply replacing one file with cmd.exe so that way when you hit a key over and over again on that logon screen, it pops up a command box running a system on that, right? I'm sure everyone's seen this. I call it movie hacking because you just hit shift 5 times and that box pops up. Now you can do whatever you want with that system. With NLA, you block the attacker's ability to have implanted that and then to reuse it if they got on that system previously. So this is probably one of my favorite slides in the whole deck. Raise your hand if you've seen this before. Keep your hand up if you've been able to implement this fully. Okay, I think I saw one person, two people. Kudos to you, see me after I have something for you. For everyone else, this is what I want you to focus on. Because with the Microsoft tiered model, tier 0 means domain admins, domain controllers, and all of the supporting systems are in that tier and can't get into another tier. And tier 1 is going to be your server admins, your servers, the management system for servers. Tier 2 is going to be your workstations, workstation admins, workstation admin system, and the management system. This means that you have to have, if you have SCCM, you've got to deploy an SCCM instance in tier 2, one in tier 1, and one in tier 0. And you have to have admin accounts in each one separately. And none of them can talk to each other. So now that many of you have your eyes glazed over and are thinking there's no way that I can do that, this is where I want to come back to. Let's focus on tier 0. Let's focus on protecting the most important assets in our Active Directory environment, our AD admins, our domain controllers. Because the issues with the Microsoft tiered model is it's difficult to implement. It's costly to implement. It requires duplicate infrastructure and admin accounts to do it correctly. It's very hard to do it correctly. There's like 3 people in this room of, let's call it 1,500, that have had it implemented. It's rarely fully implemented. There's lots of organizations that have gotten it close. So I want everyone to focus on tier 0, making sure that those are protected. So what is tier 0? Domain admins, privileged AD admin accounts and systems, or AD admins or service accounts with privileged AD rights, our AD admin workstations and servers, our ADFS and federation servers. If an attacker is able to get admin rights to an ADFS server, they can extract the certificate that's used to sign the tokens and forge their own federation tokens for 2 years or more, depending on how long that certificate's good for, anywhere on the network. So you definitely want to protect your ADFS servers. Azure AD Connect servers. A lot of organizations have gone to Office 365 and Azure AD and are using Azure AD Connect to synchronize their user accounts on their on-prem AD into Azure AD so they can use Office 365. And a lot of times they're synchronizing that password hash data into Azure AD so the users can directly log on to Azure AD. So you want to be aware that If you have Azure AD Connect servers configured, they really should be in this tier, especially if they're synchronizing that password hash data, because about every 2 minutes, Azure AD Connect is going to ask the domain controllers in each of the domains that contain users that are synchronized, say, send me the password hashes for these users. This means that Azure AD Connect is like a junior DC, because those credentials are passing through in memory on that system on a regular basis. And then, of course, PKI, Password Vault, and the Tier 0 management systems should be in Tier 0 as well. So we want to convince our admins. This is the tough part. Admins that are typically mobile, use a laptop, will require a second laptop. That's tough. It's a tough sell. They're less than excited when they're told they have to use a separate system for administration. Here you go, AD admin, here's your regular workstation, here's your new admin system. You can't use both. You can't use this to do that and the other way around. And then the biggest challenge with this is the people that are most impacted, our AD admins, are often the ones that have to make this change. They have to implement it. So guess what happens? You want me to do what? Okay, so I've got priority 1, 2, 3, 4. Guess what? It's going to be right here. I think I have time next year. How's July next year work for you? But this is a good opportunity to refresh hardware. There's several options for small, lightweight systems for these AD admin systems. I like the Microsoft Surface. Microsoft doesn't pay me to say that, but it works well, and now there's cheaper ones out. But it's important to explain the reasons, the hows, the whys, why it's important to separate these systems out. Because without that information, it will be the bottom of the priority list, and it will never happen. Because isolating these credentials are the most critical. Now, convincing management is just as important, if not more so. Got to tell them why. We've got to explain why this is important, why it's required. Yes, these systems and process will slow the resolution of issues. Managers hate this. Executives hate this. Because yes, it might take another day or two to resolve an issue that you want done in hours. But it will also slow down and stop attackers from having that access and that capability. And the cost of this extra hardware and the delays that it would take naturally to do things that used to be done a lot more quickly are far cheaper than an IR. Far cheaper than having Mandy and FireEye CrowdStrike come in and kick out the attackers. Far cheaper than the reputation hit. Far cheaper than the downtime. Far cheaper than people working 100 hours a week and 20% of your staff getting burned out and leaving. It's usually the best ones too, by the way. Start slow and build up with gradual changes. We need to partner and make this a collaborative effort. We need to start slow and say, here's what we want to do and here's why. Let's talk about how we can do this smartly, how that we can do this together. So that's a workable admin system. Ideally would be separate physical devices, but that's not always feasible. But since our goal is to isolate our credentials, let's talk about using an admin workstation that leverages virtualization so that we can have a good blend of security and operational capability. So there's a lot on this slide. We're going to start with the host OS, which is our admin environment, and virtualize our user environment into a VM. And we're going to use that user environment for all of our user activities, and that host OS is effectively going to be our admin system that we just use as a jumping point to our admin system or our DC. The account that logs onto this host OS is what I call a transition account. It doesn't have any rights, it can't do anything, it just logs onto that system. And then once on that system, we can log on to an RDB server, an admin server. So let's see what this looks like. So we have our admin workstation with our user VM. We log in as a regular user onto that VM. We use a transition account to log onto that workstation. And then we use our AD admin account via RDP to our admin server. So this way we can isolate those credentials, we can protect them. And since it's our admin workstation, it's not going to have all the standard capability of management and controls and 100 people that have admin rights. Okay, Sean, but we have a password vault. How does that fit in? You just plug it in right here. Same thing, log on as a user, use the transition account. The transition account is what also auths that password vault. But now we know the admin workstation is protecting those credentials we're using to connect into it, using MFA, hopefully. And then the password vault can proxy it through. I'm not advocating password vaults, by the way. We can have conversations offline about the benefits, et cetera. So admin workstations definitely start with our Active Directory admins. Look at virtual infrastructure, cloud admins. Don't forget about PKI and mainframe. So Chad's putting on a great talk tomorrow afternoon about mainframe hacking. From a regular workstation, a lot of times mainframes are administered that way, just like everything else is. So with this new standard, this new configuration, we want to make sure that our AD admins only ever log on to domain controllers, our AD admin workstation, or AD admin server. We want to make sure that AD admin accounts are separate from other administration. We want to prevent them from logging on to other systems. We want to get all service accounts out of AD admin groups, as a general rule. I know that can't happen right away. But our new standard is no service accounts in AD admin groups, not domain admins, not administrators. And then, of course, we want to make sure our local admin passwords actually get changed. So we need to reduce and limit our service account rights. Vendor requirements also push us in this direction. They say domain admins, we say, okay, let's push back. What rights are actually required? Too often there are domain admins, administrators, backup operators, server operators. These are highly privileged AD admin groups. Rarely do they actually require it. So I did a lot of work and effort in my free time. I read through a lot of different documentation from vendors, piled through this over hours and hours, and I put together a list of the most common things that vendors ask for. And a pattern emerged. We're in Vegas, so we're going to do a little Vegas magic. Let's see if the pattern emerges for you too. Yes, domain admins. Solves everything, right? Oftentimes it's a vulnerability scanning tool, backup, VPN, even SQL ends up in domain admins. We don't need them there. We can pull those out. They need less rights than what they say they require. Vulnerability scanning is a little trickier. Oftentimes the vulnerability scanning tool is going to use an authorized or authenticated scan using a domain admin account. But if that hiccups and leaves behind that credential of that service account on a workstation, your environment's owned. Forget about the vulnerabilities. If you have unconstrained delegation and that vulnerability scanning account scans that system, guess what? The Kerberos TGT, the authentication ticket, is left behind. If an attacker compromises that system, it's game over. We need to get better. We need to get these accounts out. Backup, unless it's Active Directory backup, doesn't need to be in domain admins, and even then it just needs to be in backup operators. VPN and SQL shouldn't be there. The issue with VPN is often the VPN service account wants to be able to reset the user's password. User is trying to VPN, their password has expired, they need to log on. Okay, well let's delegate those rights for that service account. Let's not give it DA. And SQL, I have nothing to say about SQL. I don't know why SQL would ever be in domain admins. Usually that goes way far back. A little note on SQL, by the way. A little bit of homework for you. When you get back to your organization, your Active Directory environment, take a look at your administrator account, your default administrator account for your domains, your RID 500 account, and check to see if there's a service principal name associated with it, aka a SPIN. Okay? If it has a SPIN, it's a service account. It is being used as a service account in your environment. That is bad. Please remove that immediately, because that is not good at all. So in conclusion, traditional AD administration must evolve with the threats to effectively protect AD. Most organizations have done something, but we still need to get better. Priority 1, remove all the accounts that don't belong there and remove the service accounts that are in AD admin groups. Priority 2, protect and isolate your AD admin credentials. That's been my time. Thank you very much for yours. If you like my talk, please submit an evaluation. Also, there's a QA that I'll be in this South Seas.